we're going to go through 3 different kinds of functions. We're going to go through linear, quadratic, and exponential, and just, determine, well, how can I identify all of them parts. So I'm going to start with linear with our equation y equals mx plus b. Remember, m is the slope and b is the y-intercept. Our big thing here is that we're going to have a constant rate of change. So in a table, I know that the y values and the x values are going to have a constant interval between them. So if, maybe they're upping by 3 every time. And in something like a word problem, or just a scenario, you still want to look for a constant rate of change. So maybe you're charged $8 per month, or your speed is 40 miles per hour. That constant rate of change, it's not changing, it's constant. Funny how it's named that way. And as far as a graph, it's just a straight line. And so you're really familiar with linear. A lot of you do very well with linear. Let's look at quadratic. You have 3 different forms of this equation. Where you got y equals a times x minus h squared plus k. Or you have a times x minus p times x minus q. The big thing here is I have x squared. 2 x's multiplied, that's x squared. So you're really looking for x squared. Something big that's happening with quadratic is that your second rate of change is constant. So let's go -1, 2. Let's put that in order. -2, -1, 0, 1, 2. And so, for example, you could have something like 5, 2, 1, 2, 5. And if I'm looking at the rate of change between those, from 5 to 2, we minus 3, minus 1, plus 1, plus 3. So that, I can kind of see there's a pattern there, but the big thing comes when I find my second rate of change. So the rate of change between the rate of change from -3 to -1, I add 2, -1 to +1, add 2, add 2. So that second rate of change is what tells me that this is a quadratic. And we already know that looks like a parabola. As far as there we go. All right, a scenario goes, you want like something about an increase or a decrease. You want something about a max or a min height. We talk about a soccer ball getting kicked all the time. Or maybe you'll talk about profits increase and then decrease, or maybe the shape of an arch or something like that. And lastly, we're going to talk about exponential. This one looks very different. Point is, x is in the exponent on this one. A is going to be your initial value. B is going to be your growth or decay factor. And the difference between growth and decay, it's right underneath here. With growth, your factor is going to be bigger than 1, and decay, it's going to be less than 1. And if you want your growth or decay rate, you can just take, it's basically just how far is your number away from 1. So for example, let's say I have y equals 5 times 1.12 to the x. That's going to have a 12% growth rate. Or maybe y equals 5 times 0.92. Well, 1 minus, sorry, okay, b. 0.92 minus 1 is a negative 0.08. Take the opposite value, it's a positive 0.08, which tells me that's going to be an 8% decay rate. As far as we're looking at tables, you're going to multiply or divide each time by the same number, and so you might also hear that referred to as a constant factor. You know, factor meaning multiplying. So I can see between these, for every one of them, I'm just going to be dividing by 2, which is the same as multiplying by 1/2. My graph shape is going to look something like this for growth, or for it's going to go the other way for decay, with what we call a horizontal asymptote. Okay, and with scenarios, you're just looking for that exponential growth. So if it talks about a growth or a decay rate, or if you could tell, you would have to multiply or divide. So for example, if you have a bracket, like a sports bracket, and you eliminate 1/2 of the bracket each round, and that's exponential because you're decreasing by 1/2 each time. Or a lot of things, you'll talk about like a half-life in chemistry, so like a radioactive decay. If it ever talks about like maybe something it's 1/4 of the value, like between points. The word of is like a multiplication. I think that's pretty much all you need for Unit 5.